Okay, good evening, ladies and gentlemen. This is Professor David J. Reyes. Okay. I will be presenting tonight a problem involving, or the topic may be on the topic trigonometry slash identity or identities. So this refers to the so-called study of trigonometry on the topic involving identities, meaning to bring out the solution of this one, we must have to bring out our knowledge of identities. Okay, let's proceed for tonight. So the topic for tonight is actually trigonometry. The solution should be on the so-called identities. What is given here for tonight is we are given a trigonometric function. Trigonometric meaning it involves a trigonometric function, and luckily for tonight, that trigonometric function is actually the sine function. Okay, the abbreviation is SIN. It is read sine. Okay, I will try to read the problem. We are given a trigonometric function. The given trigonometric function is sine of the quantity pi over 4 minus x closed quantity, and this should be equal to 1/2. The problem is asking what will be the value of x equal to. Meaning to say, with this given trigonometric function, what will be the value of x? So it seems we are solving an unknown or an unknown involving x. So the problem also involves algebra, because without using our knowledge of the fundamental operations and how to compute an unknown, we could not solve this problem. So actually the topic for tonight is a combination of algebra and trigonometry. Okay, let's try to bring out the solution. The given trigonometric function is actually under the form sine of the quantity capital letter A minus capital letter B closed quantity equal to. If we try to recall the expansion of this from the study of trigonometry, so because we are now on the application of the so-called identities, if we try to bring out the equivalent of this, if you try to recall it, actually from my topic trigonometry, I actually derived this one. So this is now, we are now just recalling the equivalent of this one from the previous study of the concept of identity. That is the sine of a difference of two angles. It should be the sine of the first angle times the cosine of the second angle. Okay? If this is minus, this should be minus also. Cosine of the first angle times the sine of the second angle. And for tonight, the value of A is actually pi over 4. And the equivalent of this pi over 4, this pi over 4 is actually in radians. Okay? Or the equivalent of this in terms of degrees is 45 degrees. 45 degrees. And B here, the second angle, which is subtracted from A, is actually equal to x. So B is actually equal to x. So if we try to bring out the equivalent of this by using this expansion of a sine of a difference of two angles, okay, I will just follow this one. So the sine of the quantity pi over 4 minus x closed quantity equal to, will follow this one, and we replace A by pi over 4 and B by x. So this will become sine of pi over 4 radians times cosine of the second angle. The second angle is actually B, which is actually x, the unknown. minus the cosine of the first angle, which is pi over 4, times the sine of the second angle, which is actually x. And for us to just recall the value of pi over 4, actually 2 pi is 360 degrees. This is radians. So if we divide this by 2, pi over 2 now will be equal to 360 over 2 will be 180. And again, if we try to divide this by 2, pi over 2, again we will divide that by 2, it will become pi over 4, right? And if we try to divide 180 by 4, right? It will become 45 degrees. Okay? So pi over 4, we will replace that by 45 degrees. It doesn't matter. So this will become sine of 45 degrees, cosine of x. We are following this. Cosine of 45 degrees times sine of x, and this should be equal to, the right hand side of the given trigonometric equation is 1/2, so this is 1/2. Okay? And 45 degrees, hold on, I will get my eraser. Sorry for that one, I'm getting my eraser. Oh, it's just a cloth, you know. 45 degrees is actually, for a 45 degrees, we don't have to use our calculator. For 45 degrees, they should be 1 and 1, and they should be square root of 2. So the sine of 45 degrees will be the opposite over the hypotenuse, so this will become 1 over square root of 2 times cosine of x minus cosine of 45 degrees will be the adjacent over hypotenuse, is still 1 over square root of 2. So this is 1 over square root of 2 times sine of x. And this should be equal to, the right hand side is actually 1/2 can be written can be written as 1 over square root of 2 times square root of 2, because square root of 2 times square root of 2 is actually 2. But we could write this one as simply 1 over square root of 2 times square root of 2. And the operation here is multiplication, right? So actually, we can cancel this one, a common factor. And this is actually can be written as, for simplicity, 1 over square root of 2 times 1 over square root of 2. Okay? So actually, for all the terms, we got the common term 1 over square root of 2, so we can cancel. What remains on the left will be cosine of x. This will become 1, right? So 1 times cosine of x will be cosine of x. Again, this will be 1. 1 times sine of x will be minus sine of x. And this should be equal to 1 over square root of 2 is actually 0.707. That will be square root of 2 over 2, right? So this is 1.414 divided by 2, and that will be 0.707. So the right hand side is actually 0.707. I will try to erase that one so it will look good. Would you follow it, guys? Right? So the resulting equation now is actually, it seems it is complicated because it involves a trigonometric function, okay? And it now involves the cosine and sine. So to solve x, we must have to do some manipulation. So we'll try to square both sides. We'll raise both sides to the second power. So if we try to square the right hand side, the square of cosine of x will be cosine square of x. There should be x over here, sorry. The middle term will be the product cosine of x times sine of x times 2. The middle term is minus 2 sine of x cosine of x. And for the third term, it will be sine of x to the second power. It will now become plus. So this is plus sine square of x. That's the expansion of the left hand side. And they should be equal to 0.707 quantity square. Okay, let's try to rearrange. We combine this sine square of x and cosine square of x. It will be this one here. Minus 2 sine of x cosine of x. And 0.707 quantity square is actually 1/2. So this is actually 0.5. So what will happen? This should be 1, right? Sine square of x plus cosine square of x is actually 1. This is negative. We'll transpose that to the right. Then we try to rearrange. What will come out will be twice sine of x cosine of x, and they should be equal to, this will remain on the left. Okay, we'll transpose this to the left. So 1 minus 0.5, it will be 0.5. Again, this should be the resulting equation. And for the meantime, we could not solve for x because there are still the sine function and cosine function. And again, we must to bring out our knowledge again of the sine of the double angle. We will recall that the sine of the quantity a plus b, the first one is actually a minus b, right? Sine of the quantity a plus b. If we try to expand this one, it is same as the first one, but since this is plus, this should also be plus. In which the value of a equal to b equal to x. So if we try to replace a and b by x, x plus x will now be sine of 2x, the left hand side. And this should be equal to. We are bringing out the equivalent of this in terms of a single angle, okay? Sine of x, cosine of x, we're powering this one. We replace a and b by x, so it will be sine of x, cosine of x, plus sine of x, cosine of x. They are similar. So the right hand side is actually twice sine of x, cosine of x. Okay, this is 1 plus 1, it will become 2 sine of x, cosine of x. We place it on the left. So twice sine of x, cosine of x, and this should be equal to the right hand side. This was on the left originally, we just transpose it on the right, we rearrange, and that will be equivalent to sine of 2x. So we could replace this twice sine of x, cosine of x by sine of 2x. Okay? In which sine of 2x now, the equivalent of this one will be sine of 2x, and this should be equal to 2, right? So 2x now will be equal to, we will raise both sides to negative sine to the negative 1. We are taking the arc sine, right? The arc sine of 2x will be 2x, and the arc sine of 0.5 will be the arc sine of 0.5. Okay, because we are solving for x here, we must have to eliminate this sign here, and the counter equivalent of this one is actually arc sine. The significance of this is actually arc sine. The arc sine of 2x will be 2x, and the arc sine of 0.5 will be the arc sine of 0.5. So 2x now will be equal to the arc sine of 0.5. The meaning of this one is what will be the angle, and which, if we try to take the sine value of that, it will be 0.5. Okay? It will be 0.5. So that is actually 30 degrees. If this is 1 and this is 2, 30 degrees. This is 2. This is 30 degrees. Sine of 30 degrees is actually opposite over hypotenuse. That is actually 1/2. So the meaning of this one is, what angle in which, if we try to take the sine value of that one, is actually 0.5. And the value should be 30 degrees. So 2x now will be equal to 30 degrees. If we divide both sides of the equation by 2, the value of x now is equal to 15 degrees. Okay? So that's the solution of the problem here. We could check it visually. If pi over 4 is 45 minus 15 degrees, okay, so 45 degrees minus 15 degrees is actually, this will become 30 degrees, okay, and sine of 30 degrees is it equal to 1/2. So actually 1/2 is equal to 1/2. So the solution of the problem in which the value of x is equal to 15 degrees, that's the one that will satisfy the given trigonometric equation, sine of the quantity pi over 4 minus x is equal to 1/2. Our answer here is 15 degrees. Because 45 minus 15 is 30 degrees, and the sine of 30 degrees is actually equal to 1/2. So the answer here is 50 degrees. Okay, that's it guys. That's the solution of the given trigonometric equation. And the solution of this one is actually by recalling our knowledge of the sine of the difference in sum of two angles. That is sine of the quantity a minus b and the sine of quantity a plus b. Because without recalling this sine of a minus b and sine of a plus b, we could not solve the problem, and this falls under identity. Good evening from Los Angeles. This is Professor David J. Illustrated.